Hello everyone, I'm Meng Xia, a postdoc from CMU. Today, I'm going to present our work RLens, a computer-aided visualization system for supporting reflection on language learning under distributed tutorship. As the gig economy gains popularity, where temporary flexi jobs are commonplace for efficient resource allocation, new modes of teaching and learning spring up accordingly. In particular, online language tutoring platforms, for example, Ringo, Cambly, are becoming increasingly popular. These online language tutoring platforms provide temporary jobs for native speakers to work as part-time tutors and enable language learners to have one-on-one speaking sessions with native speakers anytime and anywhere. Previous work identified that learners are experiencing highly distributed tutorship in this learning mode, in which learners distribute their learning time with different tutors. However, there is suggestive evidence that diverse tutorship might introduce lower learning improvement compared to fixed tutorship. We conducted semi-structured interviews with 16 online language learners from Ringo, a popular online tutoring platforms, to understand their requirements and difficulties for learning under distributed tutorship. These learners have sessions with more than one tutor. We asked questions including, for example, how do you calibrate your progress when you have multiple sessions with different tutors? Have you encountered any difficulties? From the interview results, we derived 4 challenges. First, learners have a hard time knowing their improvement through checking the scores of different tutors, since each tutor might have their different grading standards. Second, learners are unaware of their common language issues, for example, tense errors, as they are not sure whether they have corrected the issues or not, since previous corrections are not tracked or mentioned by different tutors in the following sessions. Third, learners are uncertain about what to do next, since suggestions given by different tutors are from diverse perspectives in each session. Fourth, it is challenging for learners to interpret detailed feedback without the context information, for example, how to map back to the transcript. Based on the challenges, we derived design requirements, and we designed different elements in the system to address those requirements. We proposed RLens, a computer-aided visualization system that allows learners to analyze and reflect their language learning progress under distributed tutorship. It utilizes natural language processing and information visualization techniques to provide data-driven evaluation scores, identify common language issues and track feedback uptake behaviors, categorize feedback, and map feedback to the context, that is a transcript.
The system has overview, correction view, suggestion view, transcript view, and filter panel. Overview shows the overall learning progress in terms of grammar accuracy, vocabulary complexity, and fluency score. Below the tutor's scores, it provides the system-calculated scores at the bottom to help learners to have a clear understanding of their learning progress by complementing tutor's scores, which may be subjective. The background color of the chart changes when the tutor changes. The bars represent the number of days between 2 lessons and show the exact count when hovered over. The window here shows the whole learning progress from the first lesson, and the selected area is magnified below. The dashed line is the regression line that shows the overall trend. The question mark here tells learners how the system score is calculated. The correction view shows the common language issues. It groups and ranks learners' common language issues in grammar, vocabulary, and fluency. The grammar mistakes tab ranks learners' grammar mistakes based on their frequency and time. These errors were extracted from tutor feedback. The system automatically tracks whether the learner still has that language issue in the following sessions. The colors in heat map corresponds to the number of the grammar mistakes in each session. Learners can check the temporal changes based on the heat map. Disabling the feedback uptake track system button allows learners to observe the errors mentioned by the tutor only. In the vocabulary view especially, in addition to the red shade that represents the count of the times the learner forgot to apply the suggested words, there is the green shade that shows how many times the learner successfully applied the suggested words. The short line in the correction view represents the lessons prior to the first feedback by any tutor in that aspect. The transcript view pops up when the correction or a grade cell is clicked. The red and green color on the scroll bar shows the position of advice or application of the advice in the transcript. For example, you can see there is an advice. By clicking that, the corrected expression will be shown. The suggestion view shows common suggestion categories mentioned by different tutors. It groups every tutor's suggestions into 6 categories. Heat map shows the distribution of suggestions for each tutor for each category. By clicking a cell in the grid, learners can see the list of suggestions given by the tutor in the respective category. In the filter panel, learners can choose different tutors, topics, or learning sessions to be displayed.
We conducted a between-subject study on a baseline system and RLens with 40 participants from Ringo. We used their real learning data for the user study. Each learner had more than 25 sessions with multiple tutors. The baseline system was constructed to simulate the language learning dashboards currently provided by Ringo platform and other learning tutoring platforms. It includes the tutor scores, the tutor feedback, and the speaking transcript. We asked the learners to do 7 reflection tasks using either baseline or RLens based on their groups. The results show that RLens is more effective and informative in helping learners to reflect on their learning progress compared to the baseline. For example, learners can more effectively identify their common language issues and understand the learning progress under distributed tutorship. And there is no significant difference in terms of the usability and visualization or interaction intuitiveness between baseline and RLens. Learners generally think the visualizations in each panel of the RLens are intuitive, and they trust the scores calculated and the information provided by RLens. We derived 3 design considerations from this study. First, organize information from the dimension of the tutor. Our user study showed that learners want to access learning data with particular tutors under distributed tutorship. Some participants compared the grading standards of different tutors to understand their actual learning performance, because they were worried that some tutors were extremely generous or harsh. In addition, many participants also evaluated their learning progress with particular tutors to decide which tutor they would like to select for future learning sessions. When learning under distributed tutorship, the diversity of tutors becomes an important factor for learners. So we suggest to organize the information from the dimension of the tutor. Second, utilize computer as a reference tutor. Distributed tutorship can provide flexible learning schedules and diversified feedback and language styles. However, tutors in distributed tutorship face challenges in maintaining the same grading standards, detecting detailed language issues, and giving continuous feedback by tracking learners' progress. We suggest that future learning tools designed for distributed tutorship should utilize the computer as a reference tutor to provide data-driven assessment and give continuous feedback, complementing the role of human tutors. Third, provide access to all information, but surface actionable information. Participants in the user study exhibit various strategies to utilize different views to analyze their learning progress, and they appreciate the access to all the learning information from different levels. However, they particularly liked the design of highlighting severe language issues in the correction view. A few participants mentioned that the excessive amount of information presented in the system made it difficult to prioritize. And the current grouping algorithms of tutors' feedback in suggestion view could be further refined to solve the conflicts of different tutors' feedback and make the suggestions more actionable. Future learning systems for distributed tutorship should surface actionable information by distilling common feedback, resolving conflicts through algorithms, and highlighting them in the interface. In this work, we contribute a computer-aided visualization system facilitating learners' reflection on the learning progress under distributed tutorship. A user study showing the effectiveness of reflecting learning progress with RLens, and a set of design considerations for computer-aided learning system under distributed tutorship. Our pipeline and designs can be generalized to other platforms that might have distributed tutorship dynamics and feedback culture. For example, online skill practice using P2P skill sharing communities, or freelance markets, for example, Upwork. There are still some limitations that we can improve. For example, the accuracy of the feedback uptake behavior, the learning curve of the system, and the evaluation metrics of English learning, for example, including pronunciation. Thank you for your attention. You are welcome to ask any question.